This conference will now be recorded.
Then we can move to the topic. Okay, let me share the screen. So let's, we have so much of information now. I don't know if you can, what is that, finish all this today, but we'll try, okay? So now the topic is, we were at this, in the yesterday session, what is that, 1 minute guys. Okay guys, let's see this. Right. So we had a very detailed discussion. We understood things very clearly. One thing is, if it is immutable, point is we cannot change it. If it is mutable, we can modify it. But while we have done a small program yesterday, we do some analysis, right? And we do, uh, and somewhere, I don't say we. I just attribute it to me only. I had little, so I had gone little deep into the analysis, and there is something, right, little missing out. Like when we try to see this is the use case. I'm again trying to come up with that so that everybody is on the same page. Also, point is today we are going to have a clear discussion because I have done a research and done the analysis, and I got the clarity there. So I understood like what is the exact difference between mutability and immutability. And we will just quickly check here. Like suppose you take an example where you take set itself, something like hash set. This can be of two forms, right? We have a hash set which is mutable and hash set which is immutable. We have two types here. So I'm taking hash set first with immutable, as we have so far we have been working with immutable. Let me create something immutable hash set, which is empty. I don't want to go with what is this uh, with elements. I'm just creating some empty hash set. Now what I'm going to do is I'm going to apply a for loop for time, just an analysis sake. Okay, some 1 to 10. And then what I'm doing is I'm saying set plus equal to I. Okay. So what I'm doing here, I'm trying to add elements to this asset. Probably. Okay. So on to this. What is the error? So no issues. Set dot. We can say. Let me put I in the parentheses here. Okay. This should work. Okay. Usually we can directly say plus equal to. Okay, probably because I have tested it today before this session. You can see here on asset only this is an empty asset. This should work. But anyway, I don't have a problem. We can do it in different styles actually. We don't have to worry about it. I said plus equal to, let me just read it there. Plus equal to is not a member of scalar comments possible. Already I have tested this. Okay, sometimes that's fine. I can still manage this, not an issue. Only is it, let me change the variable name here. Let's set and it is working with nums by each plus equal to I. Okay, that will have an impact. And of course, I'm sorry, this won't work. That's correct. It's doing correct thing. Now why, right? See, on this hash set, this is perfect. So I was looking for, this is for immutable thing. Whatever I have tried, sorry, this is for immutable. You can see this is mutable hash set. That's why it's working. Now this gives you a clarity, perfect clarity between difference between mutable and immutable. Right? When something is immutable, you cannot change it, right? Will you agree? Okay, something is immutable. Can we change that object? We cannot change it. So you see, I have created an empty hash set, which is immutable one. Now to that immutable object, I am trying to append this data. You can see there, right? This is hash set is immutable here, right? I am trying to append data on that. You can see I am trying to keep on adding 10 elements to this. As it is immutable, immediately you can see an error here, right? Means what is the point here? This is a clear conclusion. What is that? We cannot modify immutable objects. We cannot change the state of immutable objects. A small change to this, see this now. I make this mutable, then you can see the error is removed like that. Now you observe the difference now. There are two cases. In the case one, what happened? When we try to make this asset immutable, when we declare it as immutable, and when I try to append data, when I try to modify this asset object, which is immutable, I'm getting an error. What it is saying is did the error, okay, that plus equal to not a member of scalar, because right, this kind of appending or adding or modifying an immutable asset like this is not. See this. See, this gives you a perfect idea. Now remove this immutable and make it mutable. Now error is removed. See there. Now why? Because this is a mutable hash set, so that I can modify this. Are you finding the difference, sir? Are you finding the difference? But see, in both cases, variable is val type. It's not. I don't. I didn't change anything on that variable thing. Okay. In the previous one, it's val. Even now, it's val. But now, when the object is made as mutable, I am able to add data to that. I'm able to modify this object. I am able to update this object, right? Are you following this? Observing this difference. Now run this. Just run, test it now. Test the object. Okay. Of course, we are not printing it. So what should I do now? Just print it. Tell of what's it? Something like set one. Now print it and see the results. You can see a perfect set created here. Of course, insertion order is not preserved. We know that set don't preserve insertion order. That's for sure. As said, don't preserve insertion order, right? But you have all the elements, right? 1 to 10. Can you see that? It's there. Now, am I able to change this object here? Able to modify? Right? This is simple idea about mutability. Immutability means suppose if I make this immutable, see here, just a small change in the input package. You can see now this is immutable asset. Immediately you have an error. It's not allowing me to change that. Maybe if I want to, maybe if you want to change it, you can change it. How? If you change it every time a new object is created, that you have to initialize to another variable. You know that process we have clearly discussed. This point we had discussed about this point number of times. You can modify immutable object. How? Not directly on the object, but a new object is created that should be assigned to some new variable. If you try to modify it, what happens? It will try to create a new object and assign to a new variable. That's how it's possible. We have discussed this number of times, right? But now, in this case, if you see, right, what is happening here? When I try to modify this empty object and I try to update this data on immutable hash set, it's not possible. It's an error. See, it's clearly showing. Same thing, remove this and try this. See this. Now this is possible. This is what they meant. Got it right? I can modify object means see, yes, I am able to change this. Got it right? The internal thing, leave about it. If it is creating a new object after that or the old one, that is a different story. Maybe we can also test that once, whether it is trying to modify the actual but there is some difference here. We found it now. What is that? When it is immutable, we are not able to change that or update that object. When it is made mutable, I am able to update it. That small thing you can that small underlying thing you can observe carefully. That is one proper difference between mutable and immutable. Okay. Now might be I'm also going for the other test we have done yesterday. What I'm saying here is this hash code. I'm applying a hash code before change. Also, I'm applying hash code after change. Let us see if it modifies. Let's see that. Right. Let us try to run this and see the difference. But you know, this is again different. Can you see that? Probably, if I am not wrong, whenever you try to modify this even mutable hash set, a new object is created. But the difference is, what is the difference now? This is there actually. See here. Now you try to print inside, not outside. Then you get a perfect idea. You see 10 times you are updating this object, 10 different objects are created. You can see here. Leave about this now, remove this outside. Anyhow, that gets printed here. Now run this now. Probably if I'm not wrong. See, you modified it for 10 times. See there, observe carefully. There is a change every time you try to modify, even for a mutable hash set, if you modify it, internal object, then a new object is created. Means what? This concept of immutability is applicable. I mean, creating a new object is applicable for even for mutable collections. Difference. What is exact difference now? When can I say that it is mutable? When can I say it is immutable? You have seen a small use case now. Suppose if I make this immutable, then I cannot even change this now. Through this loop, I cannot modify. I cannot update it when I am making this as a immutable object. See that difference. If I am making it mutable, then the error is removed. Can see this observe this carefully. This is now I am able to update this hash set. So this concept, whenever you modify the object, a new object is created. Suppose I added one, what happened? A new object is created, one is added to that hash set, and a new address is created. How this happens is it's like this. Okay. So I just show you directly here itself. What happens now? You can have pen. First time this is empty object. One object is created. Right? This has some address, sir. It has some address. Assume that it is 10 addresses. Now you try to add one. What you are trying to do? You are modifying the object. When you try to modify, this is mutable, no doubt. Even for mutable, when you try to modify as per Scala, you know, right? Scala always see this is what Scala is. Now we get more clarity on how Scala is doing in memory, right? It is not changing the same object here also. What is that? It is not modifying, overwriting data. It's not overwriting. What is doing even for mutable hash set? You try to add something to that. Okay, you are trying to append data. Then what happened? A new object is created. That one is put into that, and this new address 11. but that 11 is assigned to the same reference is 1 here. We have same set 1 is our reference. First time set 1 is holding 10, our address is 10. Then you modify it, you add 1, then 10 is replaced with the 11. Now set 1 is pointing to this. Observe carefully. Even this is applicable for mutable hash set also. Now you try to add 2. Now what is that? Already 1 is there. It will add, it will create a new object, copy the old value to this 1, and in this again it will add a new object 1 comma 2. Now this has some new address. Assume that this is 12. I'm just an idea. Now what happens? This 12 is replaced here in the reference. Now 12 is pointing to the new address. Likewise, what happens? How many times you modify, that many new objects are created. So proof. What is the proof? This is very important because, right, when it is mutable, people thinks that, right, it might be overwritten. It's not the case of overwriting, but you are allowed to modify that. That's it. Immutable means you are not even allowed to modify when you are making it as a val type here. Can you see that? Are you getting the point here? Is that point clear or not? Finally, what is the conclusion? The nature of scalar. What is that? Like, suppose if you talk about few animals, they have some specific behaviors. If it is donkey, right? Donkey has a behavior, right? What is that? Let's think of the behavior of a donkey. It has some peculiar behavior. Likewise, you take horse. Horse has a peculiar, it's recording was. Okay. Horse has a peculiar behavior, like human has a peculiar behavior. Likewise, when you take about scalar, you have to observe carefully. Most of the time scalar is not leaving this immutability even for when you are immutability in sense at memory level. Proof is, now if you see, if it is mutable at object level, then you should not have a new address here. The same address should be kept modified, but that is not that is not happening practically. If you see, print that hash code and see, it is trying to give a new hash code. Yeah, whenever you try to modify even a mutable collection, this should be very clear. Then you ask, then where is the difference? Then that's what I am showing here. What is the difference? Then difference is this. What is that? When you make it mutable, you are allowed to modify. Suppose if you make it to immutable, see, you are not able to even append, you cannot apply this. See there, this is the difference. Means you are allowed to add something to a mutable object, remove something, and do anything on that. So that will work on a mutable object. But suppose if it is immutable, it's not allowing that. This is the difference you have to find out. I think this is clear, right? So finally, yeah, I got it somewhere in a textbook called, probably if I have opened it, I'll show you here itself. Orally, while yesterday after the session, okay, we have find it in orally. That guy have explained this scenario. So finally, I got a conclusion there. Okay. So anyhow, let's move to the next topic. Is this clear now? You understand the exact behavior of scalar and what is the exact difference between mutable objects and immutable objects. Finally, the conclusion is, when you try to modify mutable object, what happens? Don't think that the data is overwritten in one object. Still, whenever you try to modify a mutable object, every time you change, a new object is created here also. But the difference is, you can modify immutable like this. Okay, sorry, mutable like this. But the same thing you cannot do for immutable. See here now. When I try to change this, this is not allowing. If I make this immutable, this is allowing. So this is the thing you have to observe carefully. Other than that, the internal behavior, that immutability of object at object level, still that is consistent. That is persistent there. Got it right? That is there. That is there. That's what the point is. Now I will switch to the hierarchy now. Let's talk about the collection hierarchy. Yesterday we were talking about these things, and Now, as we right now, we are very clear with the difference between mutable and immutable. What is that? We also bought some small documentation from official doc. What is that? So the difference is now that this makes some sense. Immutable collection can be updated or extended. It can be modified. That means you can change, add, or remove elements of a collection as a side effect. Immutable collection, you never change. You cannot modify it. Okay. You then still again they are saying you can still right operations. You can apply operations that simulate additions, removal, or updates, but those operations will in each case return a new collection. See there, whenever you apply some what is that any method or any kind of addition or removal, it is trying to return a new collection. That new collection you have to assign to a what a new variable and leave the old collection. That muncha I don't know, that came from textbook. Okay, right, like hooray it should be. So this is point. Now finally let's go to the hierarchy now. So these are the examples. Hope maybe if you want you can also test it yourself, sir. These are the two examples. Maybe one is for immutable scenario, the other one is immutable scenario. Take 1 minute or 2 minutes time and test it and observe the difference yourselves. Okay, is that fine? Take a minute and do the testing. Switch to the other implementation classes in the hierarchy. Please test these two use cases. You can see that these two problems one by one. Then you see the difference. And I also made a comment here just to make sure you get a clarity. Probably this kind of analysis, I don't think you find in regular websites, sir. Even in most of the YouTube channels, it's not like right. I am explaining this. I'm not saying that because we are discussing, but the point is I have explored. I try to search many right materials, all that stuff, but I didn't found it. Few things we added ourselves and few things we brought it from the books. That's how it happened. There is no straightforward scenario going into this level and discussing right the actual memory level impact.
So if you use where reference variable for immutable, it will allow us to change, right?
Yes, means what? If you try to apply anything on immutable objects, that's what here. If you see the point here, see this. This is clearly saying this is coming from the official doc. It's not anything coming from. I am not putting any words into your mouth by me, but see here, what is that? A immutable collection can be updated or modified, just enough. No, don't go to anything else. So, sorry, immutable collection. I'm sorry. Immutable collection can be updated or extended in place. And in contrast to that, you can see immutable collections by contrast never change. This is the basic behavior. Right? Second thing, when you look at it now, just now you have seen one example clearly, like the impact of difference between mutable and immutable, and you find something. The other important point is, suppose if you want to still modify, apply some additions, removals, or updates on immutable objects, yes, you can apply it. But what this guy is telling us, the official guy, is saying that every time you do that, it try to return a new collection. It won't impact the old collection, that is intact. It is kept as is. But when you try to modify an immutable one, maybe you can do it. But in that scenario, it will try to return a new collection, leaving the old collection as is. Maybe I can put it as instead of uncha. Okay, I put it as is. Means no impact to the old one, but a new one is tried. Okay. And of course, one more thing. Even
So it means where are playing the important role here, right? Major role. If you give val, then it doesn't allow to change. But if you give where, it allows to change, but a separate object will be created.
no. Usually, no. If that is the case, okay. Let's again bring you. Just observe this then. What is this here? What did I put here?
It is val.
Okay, run this. Am I able to modify this object now? See this? See the object at this level. Don't look at the variable
No, no,
level.
no.
Okay.
I'm talking about the immutable. I'm talking about immutable.
Okay. See this now. Okay. I'm coming to that as well. First, observe
Okay.
this. If it is val, then you should not allow to modify this also, right? Mutable one also, right? As per the behavior of val.
Yeah, correct. But it is since explicitly we are saying that it is immutable. So that's what though we have given here val, but it is
Okay.
allowing to modify.
Okay.
But if
Suppose
you give explicitly immutable, then it doesn't allow
hmm,
for val, but it allow
even
for val.
okay. That is a different thing again. Now applying val is again what is that? It is a different scenario. I'm calling Madhu.
Yeah,
See,
yeah, yeah.
to know the difference, if you put val first, the basic, the fundamental difference here, when you have val in both the cases, when it is mutable and immutable, then you get some conclusion here. Fine, fine or not? You put val here. Am I able to change this?
No,
No.
no.
Right, means that is one thing you have to observe carefully. Okay, that gives you a clarity conclusion. Okay, when it is immutable, this is it. When it is mutable, same thing, but it is allowing change. That is the basic difference. Suppose you are putting where, means it is a different thing again.
Yeah, it allows, but a separate object will be created for that modified one.
Yeah, that happens even in case of see, even though this
Yeah,
guy,
separate object will be created for both. Yeah, when we
even
modify.
mutable also, see, it's not like it doesn't happen for mutable. Can you see this? Yeah, that's why I bought this scenario. Can you see this? Every time you change, a new object is created or not?
Yep.
Means that is applicable for even for mutable thing also, even though that is
Yeah,
meant not,
yeah.
even though actually, right, he is saying this, but actually, right, so this statement has to be modified. Whatever that is applied for immutable, the same condition is there for even for mutable. Proof you can see here. Can you see this now? But the difference is, in a scenario like this, when you make this as a var type and you try to change it, an immutable collection, this is allowing more update. But on an immutable collection, this is not allowing update. This should be a clear difference between mutable and immutable. You got it, right? Other things, suppose keeping it where and making changes, that is a different thing again. That's again another workaround. You got the point here, right, Madhu?
Yep.
Understood? So this is what many people thinks, that if it is immutable, they think one object is getting to be modified. Let me show you. I have shown a diagram here, right? They think that there will be only one object. That one object keep on overwriting. But the point is, I just want you to be clear. Even for mutable also, whenever you make a change internally, it creates a new object. See here now. That you have to keep in mind. Then you ask me a question, then what is the difference between immutable and mutable? Then if both are behaving in the same way, then how can you differentiate that? That is where this is going to be a saver for us. This is going to give us a clarity, this scenario. Okay, when you put some val and if you try to modify it, this is not allowing on immutable object. Suppose if you are making mutable, then this is allowing this. This is the one we have to take it. Following, Madhu?
Yeah.
Clear? Is that clear, or any question on that?
No. That's what I'm also saying actually. So for if you specially import that explicitly mention that immutable, for val it is not allowing to change modify, but where it is allowing to modify, but separate object will be created.
So that is
I'm
again,
adding that. Yeah.
that is again a different scenario. Again, putting var and
Okay.
working on
Fine.
is another workaround. That is not okay. That is also one more scenario, but a different one. But here,
Okay. Fine.
in this case, right? You can modify. You can modify even an immutable one also, right? Suppose you are saying that your conclusion is this, right? This is fine, no problem. But if you put var, what is the impact? That you have to see it.
Yeah, it is clear. It is clear that point.
You understood, right?
Yeah.
Other than that, I don't see, right, this what do you call the very big difference here. I'm not seeing that wide gap between mutable and immutable collection. This is one thing where I am seeing that difference here. Okay, the actual thing where you can find out some variation between mutable and immutable. In other cases, it's almost similar. Okay, got it right? So if you are clear, I will switch the discussion, Madhu. Are you good with this now?
Yeah. I'm clear.
Right. So now I'm going to talk about the hierarchy of this mutable collection. See here now. You have so many here, linear and indexed. Yesterday also I had a quick discussion. Okay. And then now let's talk about this implementation classes one by one here. I start today. I think we can discuss about stack, array stack, mutable list, linked list. If time permits, then we will talk about remaining as well, doubly linked list and synchronized stack as well. So we'll go one by one, right? So now, what is stack here? And we have discussed linked list in the discussed a couple of things in the yesterday's session about this mutable hierarchy. What is that? What is the difference between linear sequence and indexed sequence? Already we know about that. So this is not new for us. And then the next thing is a linked list. We had discussed clearly what is linked list, how it works, and a few methods we have applied here on linked list. That is in yesterday's session. Now the next scenario is stack and array stack. What is the exact difference? So these two are implementation classes in this sequence hierarchy. See, stack and array stack, direct tails of sequence. Okay, what is the difference now? Generally, stack is something, a data structure which follows a principle. Usually we call it as last in first out. What do you mean by that? Last inserted element is the first to be deleted. It's like the best example to remember stack is an idli vessel. Okay, right? If you have, because in Indian system we have this, we have the habit of eating idlis. how do you put plates on plates in a idli vessel, right? The last one you put will be the first to be removed once it is cooked properly. Similarly, here also, when you keep adding elements to a stack collection, whichever is added last, that can be removed first, but that is done through some methods. And here, for that to do insertion and deletion of elements in a stack, exclusive methods are provided, something called push and pop, where push is used to insert element into a stack, whereas pop is used to remove element from the stack. And they exclusively apply this principle. Okay, they are bound to the principle and they work according to that principle, that push and pop. Okay, so other methods behave normally. If you try to work with plus 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 minus, okay, probably they behave in the normal way. Got it right? Not plus minus, I'm sorry, plus equal to or minus equal to. If you try them, their behavior is as is. I mean, I don't think you see a big impact there. But when you apply push and pop, you understand the actual behavior of stack there, because push generally keep inserting elements and pop always removes the last element. And if you want to know, there is something called top again to the stack actually. I'll just show you. This is how the diagram of stack is. I'll draw here itself, or maybe instead of going to the paint as well, because we have a pen here. Suppose this is your stack. You have created a stack like this, and the stack has elements. It is something like a list or something like this. Now this has indexing, like right? Just I'm giving a simple analysis: 0, 1, 2, 3, 4, and right? This is called top element. Generally, this is represented with a variable called top technically. Okay, whichever is the. It doesn't mean that art. See, if I put from 0 to 4 in this from in this direction or from top to down direction, it doesn't change. Whichever is the latest one, that will be the top, and top will be always pointing to the last element that is inside. Now this is top. If you want to know what is top, then you can apply a top method, which is this is exclusively available for stack and array stack elements. Okay, so I'm not okay. This is simple analysis. Now when you push, it keeps keep adding. Whenever you say one push operation here, what happens when you say push? So one element is added. Just assume that it is one. Okay, no need of writing. Again, one more push, one more element. Suppose I am pushing 2, 2 will come here. I am pushing 3, 3 comes here. I am pushing 4, 4 comes here. If I am pushing 5, 5 comes here. When 5 comes here, every time when you push an element, top keeps incrementing. Initially, top will be pointing to the bottom of the list. It's -1. When you try to push an element, top increments, it becomes 0. And every time you add push something, top keeps on incrementing. Now, when I say pop, pop will delete an element from stack. Means suppose I say pop. By default, pop deletes this one only. Default, it will always delete the last that is inserted. Then if you try to print top, now top is not at 4. Top by default automatically decrements to 3. Suppose you do one more pop, then what happens? Again, top is decremented to 1 by 1 position. Now top will be pointing to 2. Maybe you can check all this. Now we can see some few examples to understand this practically with methods. We can apply methods and get some quick conclusion. But before that, if you understand this scenario, then automatically the behavior is very clear to you when we apply methods. So you can easily understand why you are getting some top as 3 or 4 or no 4 or 3 or 2 or 0 something, or when you push how it is working, when you pop which element is removed, after that what would be the position of top. So to understand all that, first you need to get a clear understanding of what is that the behavior of stack and how it pushes, how it pops, and how the top works, how it increments, how it decrements. When you when you push, stack increments. When you pop, what happens? When you push, top increments. When you pop, top decrements. Keep in mind, okay? We can test it now. We can prove this. We can prove these things, okay? So got it right? Anybody has any doubt on this? Try a question. Right. So now, right, one more important thing is Scala has both versions, mutable and immutable stack. Mutable stack, just now we had a discussion, we can modify it, whereas immutable stack, we can modify it. We cannot modify it. But there are ways to do that in both cases. Even on immutable stack, you can do some additions or removals in its immutable way, right? So leave about that part right now. Let's focus on what is that the methods and the behavior here, the functionality of stack now. You understand, right? So finally, how do you construct stack? Same as like how we have constructed. So far, we have built so many collections, like starting from the immutable hierarchy. We have seen how to construct hash map, or we have seen under sequence vector list all that stuff. Okay. So now when you look at this in the same way, we construct or we create this, we build this stack collection. Just create an object by using companion stuff and then add elements. That is one thing. Second thing is you can do two things on stack. Either we can push or pop. Maybe you can ask me a question, sir. Can I apply map, filter, all that? See, I have already explained all those methods within 5 or 6 sessions. So I suggest you can start, right? If you have clearly practiced those list methods, then same methods you apply on stack also. Except few things. This push pop is not available in list. Okay. So, or these are not available here. You got it right? Because push pop are specific to stack. Maybe if it is immutable stack, these methods are available there. Okay, we will check both, nothing to worry. But you got an idea, right? Got clarity here now? Now, push will insert elements, pop will remove elements. That's all. So we can see some examples here just to understand a quick idea. So if you see here, we are just creating an empty stack which takes an integer elements here. Exclusively, it will try to accept only integers because we are providing the type here. So we are saying that it is actually holding only integers. Now we are trying to just add push method. You can see by applying push, you can keep adding one element at a time. Or else if you want, you can add multiple elements at a time. That's up to you to add one at a time or to add more elements at a time. How you want to do that is up to you, okay? So this is a simple scenario. Let's quickly test it. This is a mutable stack, okay? Let's test this and get an idea. Got an idea about stack, right? Got clarity, no? Couple of things here is the bottom points to remember here is it follows a principle last in first out. There are two fundamental methods to do operations on stack: push and pop. Push insert elements, pop remove elements. Meanwhile, there is a pointer here which is called as top. When you push top increments, when you pop top decrements, these are the points to remember. Okay? And the way we construct is similar, like this is nothing new for us. The way we have done for remaining other collections, it is similar here also. It is same here even for stack. So let's test this quickly with stack thing. And we have two types of stack here. Okay, I'm removing this. I don't think this is necessary. Right? Got a clarity on this stuff. One minute. Right. So now let's go for stack. We can test both mutable and immutable. First we'll test for mutable, then we'll come back to immutable also. Val sum stack equal to. So just create a stack which is mutable. And maybe if you want just create an empty stack, probably provide the type as well. Building the workspace, nothing more than that. Okay, if you want, you can provide type. Now what you can do, stack dot application method. Stack dot push. If you want, you can add one element, or else we can add multiple elements. You can see the signature itself is showing that how to add multiple elements, right? Push. See, it's throwing an error here when I try to push, because usually, right, by default this is showing nothing. Nothing means you cannot add anything. Then what should I do? If you mention type, then it has some, the JVM understands, right? So this stack is having a type in, so this developers will add integer type of data, so we don't have a problem. When it has nothing, then there is a problem, because nothing means it doesn't allow to add anything. Right? Then what do you have to do in that case? Apply a type here. Don't forget that. Then your problem is solved. Got it, right? So now keep adding push here. Whenever you want, you can add. So I'm adding just 3 or 4 elements. Now I just want to know where my top is right now, right? So let's see what's our top now. Like println, 2 things I'll do. One, I'll print my stack. That is one thing. Second thing, I'll print the top as well. Top will be there. These are all built-in, sir. Built-in methods. You don't need to worry about it. Push is built-in, pop is built-in, top is built-in, is empty, and all other that right, that long list of methods like filter, map, reduce, all that you can apply on stack. So now you simply say what's that? Stack dot top. 1 minute. With a small typo. Stack dot top. Then just run this now for now. Then after that we apply pop, and we also test it one by one. Now you see what is your top element here from the program. You can easily understand top means the one which we add at last. That is 4. Let's see now what would be the top. Now your top will be pointing to the 4th thing. Okay. Seems like my Eclipse is a little slow today. Probably. Okay, we got the output. See there. Can you see there now? Now top is pointing to the 4th. 4 means what position? It doesn't start from 0. Top is not doesn't start from 0. It has indexing if you want. Elements has indexing. You can see, suppose you can access the elements from stack through index, because this is a implementation class of sequence. Any sequence class can use index, but index is different, that top is different. You know, right? When you push 1, top becomes 1, push 2, top becomes 2, push 3, top becomes 3, push 4, top becomes 4. Now what is that? Top is how much? 4. Suppose if you have a doubt, you do it here. Initially, if you want to understand the concept of top, right? First time print your top before you don't have any elements. After adding one element, print your top. You don't have that like indexing kind of. If it is indexing, it starts from 0. Even stack has indexing because it is an IMPL class of what? Sequence. All sequence classes, both in mutable hierarchy and immutable hierarchy, uses indexing. But that is different. Top concept is different. Don't get confused between two. Right? So now you try to keep adding top, and maybe just for analysis sake, okay, I'm just adding top stuff so that you get much more clarity here. Now just run this. Now you get a perfect idea. See, this is how, you know, right, sir? There is something like you have to split it, and then you have to break it and get into that. Somewhere Probably in the first case, I got an error because I'm applying top on this. It should be the issue. Here, usually it should return -1, but somehow for the first push, then only it is initializing top. In that method, I can understand the algorithm. Right? When we do the first push, probably then it is they are initializing top and then they were assigning some element to top. Now you understand this here. When you get if you get proper result means that's what happens. Can you see that whenever we do push, then only they are initializing top and they were trying to do that. I can implement a customized stack completely myself. Okay, right. So can you see that this is the about top? When if you push one element, then top is one. So another element top is two. Another element top is three. Another element top is. So you do pop. Interesting, right? That's how this works. But of course, when you look at that import, you can see a strike on that. It's duplicated. But you know why I'm discussing is so that if not here, somewhere else, even in Java, we have a stack concept. Might be you get a quick idea, right? There is nothing like right. Knowledge is not injurious to health, so we don't have a problem. You don't need to apply any parameter in top. By default, it will always remove the top element. Top means the something which we have inserted last. Now you can also try top now after doing pop. Probably your top will be decremented. See, you can see that also here, right? So similarly, if you want, you can do two more pops, and you can also do this push and pop with looping. Okay, if you want to add many elements, then you can do that with the looping as well. So finally, just run this. Okay. Now you know, right? After 4 again, you got 3 here. This is from where maybe the best thing here to do is to print stack as well, so that that confusion you don't have confusion. Okay, what do you do? Just run as a scalar application. Now you see there, you get a perfect idea. I applied pop, you know, right? Here I applied pop after 4. Then you can see 4 is removed. And 4 is the last element, that is insertion order is not preserved. Don't worry about that. But that is the last element which I have inserted. Am I right? This is the last element I have inserted into stack 4. And got removed. And then you can see top became 3 after that. And then I have done one more pop. And you know it removed 3. That is last but one element which I inserted into stack. Likewise, the algorithm of stack is applied on this collection. Is this clear for all of you? Even we can build a customized collection of ourselves as well. That's good actually. No, the advantage is being sometime back an assistant professor. What happened? I just need to go through this data structures. Happen. That's why I got some understanding. That's all. Okay. Maybe if you want, you can also learn it. But yes, yes, Srikanth. Definitely, this is legacy, right? That's what I am trying to tell you. Deprecated instance, these are legacy. What I mean is it possible to create empty stack? See, this is an empty stack. Someone at line 6, Sandeep. Okay. And Srikanth, to your question, yes, this is deprecated. Wherever you find that strike on that class or a method or a variable, then they are deprecated are legacy classes, legacy methods, legacy variables. Got it right? Recon. Okay, sir. But I'm just discussing because stack is something a useful data structure. Right? People discuss it number of times in number of use cases. So this knowledge might help you somewhere. That's why I have, I came up with some explanation here. That's and Sandeep, this is an empty stack only. Okay. It's possible to create any kind of empty collection, not just only stack. Okay. If you don't pass any parameters in this parenthesis, that is an empty. and still you can apply that empty method, and you can apply that create empty stack, empty collection. Okay, not just stack. It can be applied on anything. And we had a discussion when we are doing this in where we were doing when we were doing that stuff. What is that list class? Okay, got it right, sir? Sure, Madhu. I will copy and paste it. So why don't you test this problem, sir? So I hope you everybody is good with this, right? Okay. Just I'm adding to the problem to this, and we have all-in-one solution here. One shot, all methods implemented. Actually, I have made a separate one here for testing, but I put it everything in single go, one go. Right. And Madhu theory. Okay. Okay. Do you want problem as well? Okay. Okay, please test this, sir. Please test it. Take a minute and test it. Please confirm once you finish testing, sir. Then I think after that, I need to talk about array stack. Okay. See, the way we work with them is same, sir. The way we work with them is same. Like creating, adding elements, stuff is same. 1 minute. So next thing is array stack. See, when you talk about array stack, the difference between array stack and stack is array stack is not legacy, stack is legacy. How to tell that whether something is legacy or not legacy? See, when you try to import it, you can see there, when you see that strike on that any class or any method or anything like that, means it is a duplicated or it is legacy. Means legacy in sense something which is outdated now, but still we can use it. That's not a problem. So now I am creating an empty array stack here. Okay, and probably I'm adding a type also, and I think it works for same thing works for this one also. Which one? Same thing works for stack. Same push, same pop, same top. Okay, when you run it, you can see the run this. Okay, and you can see the behavior is almost same here. Immediately, you might ask me a question. Then, what is the difference between stack and array stack? See, when you look at it properly, if you can see the difference there itself. What is that? Array stack has array in that. It makes some right, some it might be little fun. That is true. Array stack array instance, I am not making right any fun here. Point is internally it uses array. This array stack internally, the underlying data structure for array stack is array, whereas for stack right, that won't be the case. It's not, it might be using array or not. I don't think it is using array in normal stack. Probably it might be using some list or linked list. Okay, normal stack internally it might use what a list or some kind of sorry, if not list, it uses some kind of linked list kind of thing. If it is mutable, internally it might be using some a linked list or mutable list kind of thing, whereas array stack uses a array as underlying data structure. Maybe if you want to be more clear, what I will do is we can just, because I have done a reasonable research on these things. Okay, maybe if we just see, go to the official doc. Okay, this is an API. Understanding this API is also important if you want to be a good developer, right? Now, I got a call from Mumbai today. The guy is asking exclusive scalar development. Of course, I'm not interested on exclusive scalar because with the big data, we have more this thing actually learning, as well as we have a lot of future for big data with stack, with scalar. So point is, but you have to understand all these things. Now, when you look at this simple, sometimes they provide this one line information, which is very useful. Can you see the simple stack class? When you say array stack, what is that? It is a simple stack class backed by array. Might be when I told that difference between stack and array stack is array means it might look little funny, even though it is funny, but the point is internally it uses array. And one more important point, can you see there? This should be significantly faster than the standard mutable stack. Right? Just now we have discussed about mutable stack. Array stack is much more faster than mutable stack. Reason is, whenever we use array has always a better performance. Right? Array has a faster access of elements. That's why performance wise, right? Array is always best fit. Got it right? So this is important difference between stack and array stack. And for stack, I try to see the underlying data structure. I try to search for that, but I couldn't find it. Maybe we'll do one thing. I'll try to check here the API. Even in API, they didn't mention anything about that underlying data structure for stack. Probably they might be using stack itself or some linked list. We don't need to worry too much about it. Maybe if you want to just see that stuff, okay, what is that? I'll just show you. Stack. Mutable stack. Let's get to that stuff here. This is the stack tree. And you can see there a stack implements a data structure which allows to store and retrieve objects in last in first out fashion. And what data structure it is using, they didn't mention it. For array stack, they mentioned they use array, but for this I didn't see any mentioning of that here. You can see probably it might be using, they might be creating a data structure which is more like stack itself, or they might be using some linked list kind of thing. That anyhow we don't need to worry too much about it. See, this is actually much more raw information. Got it right? And you need to get an idea like what is this extents here, what is this abstract sequence, what is the sequence. When you want to become really strong in some programming, usually this is what I have done when I was training people. I always try to get into the APIs first. I don't say I am really, I am a genius, but point is at least I have good understanding. That's what the point is. So you can see this, the serializable. What is the serializable? Clonable. There are few. These are very important things, right? Why people are using serializable here? Why people are using clonable? Because this matters in Java, if not in Scala. Because in Scala people don't go to that level, but Java people go to that level. Okay, you got it right. So maybe if you want, we'll have a discussion on these things as well, serializable, clonable, because these are important for you to know, right? But anyhow, it's a deprecated here. Point is this. So you got clarity, right? Array stack is that, sir. When you talk about array stack, what is the difference here? The difference between array stack and stack is that an array stack uses array as an underlying data structure. You got it right? That is one thing. And other things are same. What is that? This dynamic, this heterogeneous. Okay, if you make it generic here, this is a generic type. When if you make it generic, what happened? Somebody is asking something. If you make it generic, it is homogeneous. If you don't make it generic, then you can add heterogeneous elements. Maybe you can directly put it in the parentheses here, and you can construct that. That's fine. So those features doesn't change in most of the cases. Okay. So this is one thing, underlying data structure. Other than that, stack and array stack are almost same. It uses push and pop. It uses top thing, and all that stuff is same. Right? But this is having a better performance than array stack. So instead of stack, we can use array stack. That's why stack is deprecated or it is pushed to legacy thing. Why it is legacy? Because when you have array stack, which is giving you better performance than stack, why do you need a stack there, right? When Krishna and Mahesh Babu is there, now Mahesh Babu is giving better performance. Why do we need Krishna now? I don't say that Krishna is waste, but he is legacy. That's the point here. So same thing. So this gives you, what is that, a better performance than stack. That is also one more important point. Got it right? Array stack provides better performance because of array again, better performance than stack. That's why. Understood now? So that's why stack is deprecated. Automatically that happens, right? When something better comes, automatically the other ones will be gone into history. Same thing happened. That's clear, right? And other things, dynamic, heterogeneous, all that you can add it, sir. If you want, it is dynamic, it is heterogeneous. And by default, always you can make that as homogeneous. When something is heterogeneous, then you can always make it as homogeneous. Got it right? Next one. Insertion order, you can see there, probably it's not preserving insertion order. When you look at that, for array thing, it should preserve. We will check this one. Insertion order. For stack, it is not preserving. One quick, let's have a quick look at it. If it is stack, you can see I'm inserting 1, 2, 3, 4. But when I print it, what is that I am getting here? You can see there I got uh, let's put it as a stack here. I'm sorry, I'm trying modifying that. Even for array stack, insertion order is not present because when I put 1, 2, 3, 4, I should get 1, 2, 3, 4, but it's not going in the same order. Let me apply same for stack as well. Let's see what happens. Okay, let's import both. It's asking me. Now the error will be removed. Now you can see that it's not going as per the order. You can see this. It's coming with 4 3 2 1. It's coming in the reverse way. Okay, because probably as you are saying last in first out, it's keeping elements as per that. Okay, the last element will be put it into the first position. See there, that's what it is doing. So it's doing some kind of priority. When there is a priority, there is no guarantee that insertion order is preserved. Okay, probably I would like to do one more quick check on this. Okay, same thing is applicable even on array stack as well. If you look at this, it is not preserving insertion order. Both are not preserving, even though they belong to a class of sequence, right? Family of sequence. Still, these two are not preserving insertion order. One more important thing to concentrate. Because might be you can ask me. Usually, sequence has some that indexing, right, sir? So when there is indexing, why can't this preserve insertion order? Why it's not doing that? Reason is simple. Here there is a priority involved. When you have a priority involved, index doesn't matter here. Got it right? It's like, you are standing in a queue for a ticket, movie ticket. Assume that nowadays we have book my show. I'm just giving a quick example. Suppose you have a priority, then automatically last one will come first, right? When you are a VIP or VVIP or something else, you come first. Then indexing doesn't matter there. That doesn't come into the picture at all. Because that also another important point is it depends on the underlying data structure and the algorithm, how it behaves, the algorithm is behaving. That is also important. Are you following, sir? So that is simple analysis on this. So both of these are not preserving insertion order. But one more quick scenario is I'm just adding elements like this. Let me check like this. Something like 10, some 5, some 4. I don't want 4, already 4 is there. Some 6, some 2. Okay, let it be. This allows duplicates. We don't have a problem, right? That is the nature of sequence family. Sequence families allows duplicates. Right? Now let me run this. Also one more thing. Let me print it. Print ln of just before applying push and pop. Let's just print what would be the part here. Right. Can you see there now? When we go with the normal approach, general approach, then it is preserving insertion. Can you see that? When you are applying push and pop, the whole behavior changes. See, got the point, right? It's like a quick example to remember is when you are at home, you are like having a push and pop on you. So you have a priority how to work as per the partner, right? But when you are in office, you work with your own terms, like that array stack. I am not married. I am not that deep into that. Okay, wife and husband things. Okay. So point is, I'm just giving you. Maybe if you directly try to pass elements to the array stack, and when you print it, then it is doing as behaving in a regular sequence thing. But when you're applying push and pop, the total behavior changes. Like when you come from office to family, you are a totally different man. So to a home, sorry, your behavior completely changes. Correct? Even someone, a strict manager in office, when he comes home, he's something else. Am I right? That's it. Same thing here. When you add elements directly, the behavior is different. When you're applying push and pop, the behavior is different. I'm just only trying to say, make some fun, but I don't know whether it makes any sense or not. That's all. You got clarity, right? And one more thing, still you can apply indexing here. Maybe if you have a doubt, these are belonging to sequence family. The advantage with sequence family is on any sequence family, index is there. So maybe top is different. Suppose I want to get element from first index, then what I can do, I can simply say println of, I can say, still we can choose index. Always remember, if it is a sequence family, sequence can choose an index as well, even if it is belonging to linear sequence or indexed sequence. You can see there 10 is coming there. Can you see that? From 0, I am able to extract 10 by using the index. That's also possible. Following, sir. So this is another important thing to remember. So, but anyhow, so finally, what is the point here? There are two cases here. Insertion order is preserved when you are not applying push and pop. Means it's behaving more like a sequence. When you're applying push and pop, there's a change in the behavior because a priority is coming into the picture there. That's what we are observing. I'm not, right. We are not concluding this directly. We are doing a workaround here. From workaround, we are concluding things, right? With proofs, we are trying to understand. So finally, so what is the point? Finally, what should I say here? What about insertion order of array stack? Insertion order is not preserved when we apply push and pop. When you apply or when we insert elements through push method. Otherwise, we can see that is intact as is. We don't have an issue there. When we insert elements, otherwise let me be more clear. Elements with what, sir? With push method. Else what, sir? Insertion order is preserved. Let's make it in one point. So what else? You can have duplicates. I try to put some duplicate here. You can see somewhere. I put 2. Still 2 is coming to me. It is not removing duplicates because that is one behavior of sequence, right? Sequence family always allows duplicates. Okay, duplicates are allowed. Same thing almost for stack also. Only difference is the underlying data structure changes. What else, sir? If you want, you can add nulls, all that. Okay, null means when it is heterogeneous, null is allowed. There is we don't need to. That discussion is clear there. Maybe I'm adding few more points here with the stack. Okay, because these are important observations. Every time when you are using a data structure in collections, even in Java, these 4 or 5 features, there is a dynamic thing is quite common for all collections. Heterogeneous, insertion order, then duplicates, unique. You have to check these things. For a sequence, we don't have a problem of unique because elements are always what is that, sir? Always we can have duplicates there. It doesn't mean that we should forcibly add duplicates, but if it is necessary, we can add. Got it, right? This is other important observation conclusions. And program is as usual there. Same thing is applicable here also. What is that? Also, maybe I just need to make a small change to this. Now I'm talking about stack here. Stack doesn't provide better performance than array stack. Okay? And also, it doesn't use underlying data structure as what array. So even that's not clearly mentioned, so I'm just not getting into that point there. So it is dynamic, heterogeneous. Insertion order is not preserved when we insert elements with push, else order is preserved. Duplicates are allowed. We know that. What does this mean? Of course, both uses some priority. What is that? Array stack and stack both uses some priority. What is that? Last in, first out. Okay. It also follows a priority. What is that for priority, sir? Follows a priority. This priority of this is last in, first out. Suppose if it is a queue follows first in, first out. We'll come to that as well. LIFO, people call it as in short form. It means last in, first out, sir. So that's all, sir. I think this is enough. This is more than enough on this. Okay. That's all, sir. That's about this stack, stack, linked list. So we have come across different hierarchies here. So what did we do? Linked list, stack, array stack. Yeah, mutable list. Anyhow, we will. That is also almost similar to list. The difference is mutable list we can modify, list we cannot modify. That's the difference. And synchronized stuff, that's not something due to synchronize stack means it is thread safe. I'll discuss this in the next session. So there are few more implementation classes here. Probably tomorrow I try to cover some 3 or 4 tomorrow. And then by this right month end, I would like to close this Scala and I would like to jump to Spark actually. From July 1st, probably I'll fix a date. If anything is there on Scala, I'll plan on weekends. If I should cover more on Scala, Still, we'll plan weekend sessions like how we are doing right now. And if you want to learn more programming, okay. Shall we stop here? I think we have done. Any more questions? I think we are missing Bharat today. Hope all of you are good, right? Sudarshan, Sunil, Deepak, Madhu Reddy, Rohan, Srikanth, all of you are fine, right? Sandeep. Yeah, we will go for Spark, Sandeep, from July 1st, okay? That schedule is fixed. So we'll plan from July 1st. Right. Any more questions? So we'll stop here, and tomorrow I'll continue more on this. I'll come up with more, that workaround I have in mind. I'm not going to leave that. We are going to do as many solve as many problems as possible. That workarounds I'll plan on weekends. Whenever, right, if we have time, we will do the workarounds. We will finish exception handling, then we will go for Spark. No problem. Sure, Sandeep. We'll do that. So if anything is there, I told you, right, we can plan on weekends. Suppose something is there in Scalar to be discussed, we can discuss on weekends. Got it, right? Don't worry. We don't leave anything there. We will try to pull as much as possible. Okay. So already we have 60 sessions done on exclusive Scalar, and still I am expecting some 10 more sessions or more than that. So probably we might get for only Scalar around 75 to 80 sessions. Means what? 75 to 80 hours means it's more than 3 months of Scalar training. Okay, that's more than enough for Spark. If you have questions, then I can do more on weekends as well. I don't have a problem. Shall we stop here then? Have a good day. Happy weekend. See you.